So we've got class tomorrow, and I kind of thought I should make a quick little video. You know, like one of those Mr. Quirk 10-minute videos. It's like a really quick video to talk about some things that we can talk about outside of class that we hadn't talked about previously. You know what I'm saying? So, this is Quirk. One of those being, what is the derivative of sine, and what's the derivative of cosine? You know, we haven't talked about that yet. And so, that's not power rule, right? If I want to know the derivative of sine, I just know that it's cosine. See how easy that is? That's really messy though, actually. So the derivative with respect to x of the sine x function is cosine x. How do you know that? You know that because if your function is sine x, what is f prime of x? F prime of x is the limit as delta x approaches 0 of f of x plus delta x. Now, if my function is sine x, then it's sine of x plus delta x, right? Minus f of x. What is f of x if my function is f of x equals sine x? F of x is sine x all over delta x. So how do I know that the derivative of sine is cosine? Well, I could remember that the derivative of sine is cosine. Or I could do the limit as delta x approaches 0 of the sine of x plus delta x minus the sine of x all over delta x. Figure it out, which is always more fun. So the next step, though, in doing this is you might think, well, I'm going to plug in 0 for delta x, and that gives you 0 over 0, which means do more math. And what is the do more math now? The do more math here is to remember one of our sum formulas specifically for sine from pre-calculus, okay? And in trigonometry, we had these formulas. This is why it's sort of important that I show them to you back then and remind them to you now, because I'm pretty sure you've forgotten. The sine of x plus delta x is actually the sine of x times the cosine of delta x plus the cosine of x times the sine of delta x. Okay, and then there's a minus sine x all over delta x. And so one of the reasons why I talk about this identity in the junior pre-calculus class is because I know we're going to need it to prove the derivative of sine, less than a year later. And so the good news is we know that the derivative of sine is cosine, right? So what is going to happen now? What is going to happen now is, and I'm doing this on a fly just for fun, I'm going to rearrange some terms. Maybe I'll pick a new color real quick. See how this has got a sine x cosine x, and this has a minus sine x? Right. So if I were to switch these terms around real quick, I could out a sine x, right? Limit delta x approaches 0. I could a sine x, and that would leave me with a cosine x minus 1 and a plus cosine x sine x delta x. Sorry, shoot. This is delta x. And this is all over delta x. Okay. Take a second and stare at that. Took the three terms on top. I put the first one and the last one closer together and sine x out of it, right? And then I just left this term the same. That's all I did. Okay, it's all over a common denominator. But what I can do with a common denominator that's kind of different is I could choose to break this into separate denominators like this. And something actually just hit me this very, very moment. That's kind of important, but what you gonna do, you know? Um, Man, at the end of last year, um, we had COVID. Oh, damn it! Is it even worth doing this anymore? What's the point of any of this, right? My mirroring thing quit working. So there's actually a couple of limit formulas that we didn't talk about last year because of the whole like COVID thing. Look, Mary. Um, the limit of cosine x minus 1 over delta x, that's like times sine x. um, the, the cosine x minus 1 over delta x as delta x approaches 0, this is a special trig limit that we would have talked about last year, that when we were doing our unit on limits. And it just hit me. I was like, wait a minute. I don't think we talked about these things. Uh, Plus, see, I can distribute the limit as delta x approaches 0 over here to sine delta x over delta x. What I'm choosing to do is just rewrite the factors that involve delta x together, right? See how this sine x right here doesn't have a delta x, and this cosine x over here doesn't have a delta x, okay? Inside the parentheses, I have two separate limits. So I basically distributed the limit just now, which is fine to do. So all I've done was use an identity, rewrite the sum of this sine, the angle on the sine, and then separate them out. And this is something that we didn't learn last year. This thing right here is equal to 0. And what's 0 times sine x? That's 0. Plus, inside this parentheses, what's the limit as delta x approaches 0 of sine delta x over delta x? That's 1 times cosine x. And what's 1 times cosine x? 1 times cosine x is cosine. What's cosine plus 0? Cosine plus 0 is cosine. So what is the derivative? The derivative f prime of x is cosine x. That's the derivative of sine. Remember my function, f of x was sine. What's the derivative of sine? Derivative of sine's cosine. So I like to do this every year. This one example to show you that uh, when it comes to derivatives, we have this formula. The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. This limit definition of a derivative. The limit definition of a derivative. I'm going to do it this way. You can see all of it at once. This limit definition of the derivative right here. It's a big deal, right? Once I prove this limit definition works for, say, power rule or the derivative of sine, or I prove that it works for the product rule, which is something that's coming up this week, or I prove that it works for the quotient rule, or I prove that this limit definition works for the chain rule. When I start proving this limit definition works for these other things, like it makes those other rules true, then I don't have to use the dang limits anymore. Okay, so the limit definition is important, but we're going to get past it. Okay, if you don't want to get past it, and there it goes. What you have to do is you have to memorize that the derivative of sine is what? Derivative of sine is cosine. Derivative of sine is cosine. So something else I thought I could do with us besides just this derivative of sine thing. Mary, there we just proved the derivative of sine. Is also talk about writing an equation of a tangent line, or just basically the equation of a line. Maybe that's a good place to start. Equation of a line. Because the question will be asked a whole bunch of times. What is the equation of the tangent line? Okay, so equation of a line. In case you forgot, right? You need a slope like let's say 7, and you need a point, like let's say 13,74, right? To write the equation line, you need two things: a slope and a point, slope and a point, slope and a point. And we have y minus the y coordinate equals the slope times x minus the x coordinate. We did this last year in pre-calculus, but as we've done already with the power rule in finding the slope of a tangent line, right? What's the slope of a tangent line? The biggest question really of all is what is the equation of the tangent line? Guarantee you on the AP exam coming up this May, there will be at least one AP exam question about equation of a tangent line. Like it's just definitely a thing. So I thought I'd throw it in this video real quick just to remind you of how to write a line. So you have y is the y coordinate minus what's the x coordinate? I mean the y1 is the y coordinate. So what's the y coordinate? That's 74 equals the slope. What's the slope? The slope was the 7 times x minus the x coordinate. And that right there is your equation of a line. You can leave the equation like that. You do not have to put it in y equals mx plus b form. And that's tough because since like 6th grade, you had y equals mx plus b like programmed into your head. You know, that's just like how it was. You know, that was like your life. Y equals mx plus b, y equals mx plus b, y equals mx plus b. But if it's a free response question on the AP exam, you want to leave it like that. Because if you now put it in y equals mx plus b form, you could make a mistake. So writing the equation in point slope form, point slope form means you need a point and a slope. Okay, point and a slope, that's all you need. You're going to get the slope from the derivative with these tangent lines. You're going to take a derivative, plug in the number, find the slope, which was a part of your homework last week, right? You're going to have a point because in order to get the derivative at a point, you got to know the point. So if you have a point and you have a slope, you can write the point slope form of a line, okay? So this is something I wanted to mention now before class. So maybe you're going to watch this video before class, maybe not, I don't know. But y minus y1 equals the slope times x minus x1. That needs to be your new friend for the equation of a line, okay? The other thing that I forgot to mention just a minute ago when we were on the other page is the derivative of sine is what? Cosine. What's the derivative of cosine? Derivative of cosine x with respect to x. It's negative sine. Exactly. I heard you all saying it. So these are two rules that are not really power rule, right? And I'm not multiplying the coefficient times the exponent and then dropping the exponent down one, right? What I'm doing is I'm just memorizing these rules because I don't want to have to do the limit as delta x approaches 0 of fx plus delta x minus fx all over delta x, right? Makes sense? So these are two new rules. They're in the same section. These two formulas right here are in the power rule section, okay? And so now that I've mentioned it, that'll just save us some time tomorrow. If you watch this video, tonight. Anyway, I'll let you go now. Bye.